Today's lesson objective, students will use midsegments to solve problems. So first of all, what is a midsegment? A midsegment is a segment that connects the midpoints of two sides of a triangle. So for instance, if I have a midpoint here and a midpoint here, the segment between them would be the midsegment. And a triangle can have three midsegments because there are, after all, three midpoints. And so each of those would be a midsegment. And then it cuts the sides of the triangles into congruent pieces. Because, of course, the midpoint is in the middle. Okay, so the midsegment theorem says that the midsegment is parallel to a side, and it's half as long as that side that it's parallel to. So, for instance, in my picture here, I have the DE. I can see that it's a midsegment because of these congruent pieces here and these here. So I know that DE is a midsegment. And so by the midsegment theorem, I know that DE is parallel to AC. And I also know that DE is half as long as AC. Or the other way you could think of it is that AC is twice as long as DE. So for example 1, I'm given this figure. And I'm to determine how long DF and AB are. So first of all, if I look at DF, and this is with them being midsegments, that should have been given. So DF is going to be parallel to BC and half as long as BC. So DF is going to equal half of BC. And so since BC is 90, I know that DF has to be half of 90, so DF would equal 45 inches. And then for the second half, we're looking at AB, which is this whole length here. Well, the midsegment is 45, and so AB has to equal 2 of those midsegments, 2 times EF, so 2 times 45, so AB would equal 90. Now, suppose if in this triangle we drew a midsegment opposite DF, what would its length be? Okay, so I'm going to go ahead and do that. I'm going to draw a midsegment here, which means this is congruent and that's congruent. And we found that, and I'm just going to call it GH so we know what we're talking about here. Okay, so we found that DF was equal to 45 inches, and I know that GH is going to have to be half of that. And so it's going to be 22.5 inches. So on this next slide, I have some for you to try on your own. And so first of all, we have DE as a midsegment of triangle ABC. We're going to find the value of X on each of these. So for letter A, pause the video if you need to. Okay, so because this is 32 and X is the length of the midsegment, I know that it has to be half of 32, so in this case, X would equal 16. Okay, here's another one for you. In this case, my mid-segment is equal to 8, and so x would have to be twice as long, and so 2 times 8, x equals 16 again on this one. And then the last one, again, pause the video if you need a moment to think about it. Okay, so since ED is a midsegment, I know that AE has to be congruent to EC because it goes to the midpoint. So in this case, you're not cutting anything in half. X just equals 17 because E is the midpoint of AC. All right, here's some other examples using properties of midsegments. So we're going to use triangle GHJ, where D, E, and F are midpoints of the sides. And if DE is equal to 4x plus 5, and GJ is equal to 3x plus 25, what is the length of DE? So first of all, you have to think about, okay, it takes 2 DEs to equal just 1 GJ, because GJ is twice as long as DE. So you have to make sure you remember to multiply the expression for DE times 2. So 2 times 4x plus 5 is going to equal 3x plus 25. So if I go ahead and distribute, I get 8x plus 10 is equal to 3x plus 25. And then I subtract 3x from both sides, and subtract 10 from both sides. And I get that 5x is equal to 15, and so x equals 3. Am I done with the problem, though? No, I'm not. It wants me to find DE, so I have to remember to go back and plug that in. And so DE with 4x plus 5, so 4 times 3 plus 5, which is 12 plus 5. And so DE would equal 17. Okay, so using the same figure, suppose that EF is 2x plus 7 and GH is 5x minus 1. So now I'm looking at EF and GH. So it's a similar situation to the last one. Pause the video, see if you can figure this one out for yourself. Make sure you remember that it takes 2 EFs to equal 1 GH. Use that to set it up. Okay, so when you plugged it in, you should have said 2 times 2x plus 7 was equal to 5x minus 1, and you solve that. You get that x is equal to 15. Go back and plug that in for EF, and you should have gotten that EF was 37. Okay, so now we're going to use this mid-segment theorem in a proof. So first of all, we're given that QS is equal to SP. So those two are going to be congruent. And we're given that PT is equal to TR. And we're going to prove that QR is parallel to ST. So starting off with what I'm given, because those segments are congruent, I know that S is the midpoint of QP. And I know that T is the midpoint of PR. And I know that because that's the definition of a midpoint. So therefore, if those are both midpoints, that means that ST is a midsegment. By the definition of a midsegment. And therefore, by the midsegment theorem, I know that QR is parallel to ST. So in order to use this in a proof, you need to first say that it is a midsegment, and then you can say it's parallel to the third side. And that concludes this video. Thank you.